Hello! Before we start, kindly subscribe to my channel and like the video. Our lesson today: subtracting polynomials. Lesson 5 to 5. How to subtract polynomials. To subtract polynomials, add the opposite of the second polynomial. Then combine like terms together. You can subtract horizontally or vertically. Example. Subtract x squared plus 4x plus 7 minus negative 2x squared minus 3. Subtract polynomials horizontally. X squared plus 4x plus 7 minus negative 2x squared minus 3. Add the opposite. X squared plus 4x plus 7 plus 2x squared plus 3. Group like terms. X squared plus 2x squared plus 4x plus 7 plus 3. Combine like terms. 3x squared plus 4x plus 10. So the difference is 3x squared plus 4x plus 10. Subtract x squared plus 4xy minus 5y squared minus negative 2x squared minus 3xy plus 4y squared. Subtract polynomials vertically. X squared plus 4xy minus 5y squared minus negative 2x squared minus 3xy plus 4y squared. To subtract, add the opposite. X squared plus 4xy minus 5y squared, arrange in columns. Plus 2x squared plus 3xy minus 4y squared, add. 3x squared plus 7xy minus 9y squared. So the difference is 3x squared plus 7x, y minus 9y squared. Question 1. 7k plus 6 minus negative 2k plus 3. 7k plus 6 plus 2k minus 3. Answer, 9k plus 3. Question 2. Negative 3y squared plus 7 minus 2y squared plus 4. Negative 3y squared plus 7 minus 2y squared minus 4. Answer, negative 5y squared plus 3. Question 3. 17k squared minus 23 minus 9k squared minus 25. 17k squared minus 23 minus 9k squared plus 25. Answer, 8k squared plus 2. Question 4. X squared plus 6 minus 3x squared minus 2. X squared plus 6 minus 3x squared plus 2. Answer, negative 2x squared plus 8. Question 5. 7x squared minus 12 minus 4x squared minus 21. 7x squared minus 12 minus 4x squared plus 21. Answer, 3x squared plus 9. Question 6. X squared minus 8x minus 4x minus 5x squared. X squared minus 8x minus 4x plus 5x squared. Answer, 6x squared minus 12x. Question 7. 3x squared plus 2x minus 4x minus 6x squared. 3x squared plus 2x minus 4x plus 6x squared. Answer, 9x squared minus 2x. Question 8. 7x squared minus 24y squared minus negative 11x squared minus 12y squared. 7x squared minus 24y squared plus 11x squared plus 12y squared. Answer, 18x squared minus 12y squared. Question 9. Negative 5p squared plus 13q squared minus 9q squared minus 22p squared. Negative 5p squared plus 13q squared minus 9q squared plus 22p squared. Answer, 17p squared plus 4q squared. Question 10. For a squared plus 9ab minus negative 4ab plus 2a squared. For a squared plus 9ab plus 4ab minus 2a squared. Answer, 2a squared plus 13ab. Question 11. For a squared b squared plus 6a minus 9a squared b squared minus 3a. For a squared b squared plus 6a minus 9a squared b squared plus 3a. Answer, negative 5a squared b squared plus 9a. Question 12. For ab squared minus 3a squared minus 9ab squared plus 2a squared. For ab squared minus 3a squared minus 9ab squared minus 2a squared. Answer, negative 5ab squared minus 5a squared. Question 13. 2x squared plus 6x minus 14 minus 8x squared plus 11x plus 12. 2x squared plus 6x minus 14 minus 8x squared minus 11x minus 12. Answer, negative 6x squared minus 5x minus 26. Question 14. X squared plus 19x minus 4 minus 6x squared minus 8x plus 13. X squared plus 19x minus 4 minus 6x squared plus 8x minus 13. Answer, negative 5x squared plus 27x minus 17. Thank you. Hey again. Today we will solve page 141, Degree of a Polynomial, from the Sadlier Oxford Practice Book, Grade 8. Question number 1. A squared minus 16 degree 2, because highest power is 2. Question number 2. 15 degrees 0, because constant. Question number 3. 3x plus 7 degree 1, because highest power is 1. Question number 4. S cubed degree 3, because highest power is 3. Question number 5. 15 is squared plus b degree 2, because highest power is 2. Question number 6. X squared plus 2x plus 1 degree 2, because highest power is 2. Question number 7. 9 minus or degree 1, because highest power is 1. Question number 8. For x squared plus 6xy plus 1 degree 2, because highest total power is 2. Question number 9. R squared s squared plus r s degree 4, because 2 plus 2 is equal to 4. Question number 10. 2z cubed plus 4z squared minus z degree 3, because highest power is 3. Question number 11. Negative 1 degree 0, because constant. Question number 12. Negative 2x squared y squared z minus 3x cubed degree 5, because 2 plus 2 plus 1 is equal to 5. Question number 13. 2x cubed plus 8 minus 9x squared equals 2x cubed minus 9x squared plus 8, ordered by descending powers. Question number 14. 6x plus 17 plus 11x squared equals 11x squared plus 6x plus 17, ordered highest power first. Question number 15. X squared plus x cubed equals x cubed plus x squared plus x, rearranged to descending order. Question number 16. 7 minus x squared equals negative x squared plus 7, highest power first. Question number 17. B squared plus 4b cubed minus 2b to the fourth minus 9 equals negative 2b to the fourth plus 4b cubed plus b squared minus 9, ordered descending powers. Question number 18. 3s plus 14 plus s cubed minus 7. 14 minus 7 is 7. Equals s cubed plus 3s plus 7, combine constants in order. Question number 19. 6x cubed minus 9.5 plus 3x squared plus 6.5. Negative 9.5 plus 6.5 is negative 3. Equals 6x cubed plus 3x squared minus 3, combine constants in order. Question number 20. A squared x cubed minus 5 plus a cubed x to the sixth equals a cubed x to the sixth plus a squared x cubed minus 5, combine constants in order. I will leave the balance exercises for you to practice. Thank you. Please subscribe to my channel for more math educational videos. Our lesson today: add polynomials, and we will solve down page 145. From question 1 to question 14. To add polynomials, combine like terms. You can add polynomials horizontally or vertically. Add 4x squared plus 7x plus 9 plus negative 3x squared minus 4. Add polynomials horizontally. 4x squared plus 7x plus 9 plus negative 3x squared minus 4 equals 4x squared plus negative 3x squared plus 7x plus 9 plus negative 4 equals x squared plus 7x plus 5. Simplify. So the sum is x squared plus 7x plus 5. Add polynomials vertically. 2x squared plus 4xy plus 7y squared plus 5x squared minus xy minus 8y squared. Group like terms. 2x squared plus 4xy plus 7y squared plus 5x squared minus xy minus 8y squared. Add 7x squared plus 3xy minus 1y squared. So the sum is 7x squared plus 3xy minus y squared. Question 1. 2x squared minus 7x minus 3 plus 4x squared minus 3x plus 6. 2x squared plus 4x squared minus 7x minus 3x minus 3 plus 6. Answer: 6x squared minus 10x plus 3. Question 2. 4x squared minus 7x plus 3 plus 2x squared plus 2x minus 7. 4x squared plus 2x squared minus 7x plus 2x plus 3 minus 7. Answer: 6x squared minus 5x minus 4. Question 3. 3x squared plus 4x minus 3 plus 5x squared minus 6x plus 3. 3x squared plus 5x squared plus 4x minus 6x minus 3 plus 3. Answer: 8x squared minus 2x. Question 4. 2x squared plus 6x plus 4 plus x squared minus 7x plus 4. 2x squared plus x squared plus 6x minus 7x plus 4 plus 4. Answer: 3x squared minus x plus 8. Question 5. 6n squared plus 4n minus 3 plus negative 9n squared minus 4n plus 7. 6n squared minus 9n squared plus 4n minus 3 plus 7. Answer: negative 3n squared plus 4. Question 6. 2x squared minus 2x minus 3 plus 3x squared minus 2x plus 3. 2x squared plus 3x squared minus 2x minus 3 plus 3. Answer: 5x squared minus 4x. Question 7. 42x squared minus 36x plus 64 plus 28x squared plus 11x. 42x squared plus 28x squared minus 36x plus 11x plus 64. Answer: 70x squared minus 25x plus 64. Question 8. X squared minus 23x plus 14 plus 6x squared minus 8. X squared plus 6x squared minus 23x plus 14 minus 8. Answer: 7x squared minus 23x plus 6. Question 9. 7x plus 2 plus 4x squared plus 6x minus 4. 4x squared plus 7x plus 6x plus 2 minus 4. Answer: 4x squared plus 13x minus 2. Question 10. 3x squared plus 2x minus 7x plus 6x squared plus 4. 3x squared plus 6x squared plus 2x minus 7x plus 4. Answer: 9x squared minus 5x plus 4. Practice by solving the remaining exercises. Question 11. Negative 4t squared minus 8t plus 96 plus 30t squared minus 102. Question 12. 61x squared minus 128 plus 44x plus 17. Question 13. 45x cubed minus 22 plus 19x plus negative 24x plus 17x cubed plus 19. Question 14. 5a minus 4a squared plus 7 plus 12a squared minus 9 minus 6a. Answer question 11. 26t squared minus 8t minus 6. Answer question 12. 61x squared plus 44x minus 111. Answer question 13. 62x cubed minus 5x minus 3. Answer question 14. 8a squared minus a minus 2. Thank you. Keep practicing adding polynomials.
Hello everyone, and welcome to today's presentation. We're going to explore the objective of multiplying monomials and polynomials. Our focus will be on multiplying two monomials, as well as multiplying a polynomial by a monomial. We'll also look into the concept of multiplying by monomials in general. This is the first slide, so I just want to give you a quick overview of what we'll cover today. I'm excited to get started, so let's dive into the topic. Let's talk about how we can model the multiplication of two monomials using a rectangle. Think of it this way. The factors, or the numbers we're multiplying, become the length and the width of a rectangle. The area of this rectangle then represents the product of the two monomials. For example, if we multiply 2x by 3x, we assign one factor to the width and the other to the length. So the width is 2x and the length is 3x. When we multiply these, we're essentially finding the area of the rectangle, which gives us the product. Now, to help visualize this process, we use algebra tiles. These tiles make it easier to see how the multiplication works out in a geometric way. By modeling the factors as tiles, we can see how their combination leads us to the product, reinforcing our understanding of monomial multiplication. This approach connects the algebraic process to a visual and tangible method, making the concept clearer and more intuitive. All right, let's take a closer look at this diagram. We see that the rectangle is made up of 6 square tiles. Each of these tiles has an area of x squared, which means that if we measure one side of a tile, its length is. When we add up all these tiles, the total area becomes 6 times squared. Now notice how we can also express this area as a product of two binomials, 2x and 3x. Multiplying these together, we get 6x squared, which matches our total. This is a simple yet powerful way to understand how the area of a rectangle can be broken down into smaller parts and then combined through multiplication. So the key takeaway here is that counting the individual tiles helps us see how the total area is composed, and expressing it as a product shows the relationship between the dimensions and the area. This concept is fundamental as we explore more complex shapes and their dimensions throughout this presentation. Let's walk through this example to see how we multiply two monomials step by step. We start with minus 3x2 multiplied by 8x5 to make it clearer. We break it down into parts. First, multiply the coefficients, which are an 8. That gives us. Next, we multiply the variables, which are x2 and x5 since the bases are the same. We keep the base and add the exponents. So 2 plus 5 equals 7, making it. Putting it all together, we get minus 24x7, remember. The key points here are, first, multiply the coefficients, second, multiply the variables, and third, add the exponents when the variables have the same base. This process is essential because it helps us simplify and work with algebraic expressions efficiently. And as a quick reminder, the rule am times n equals am plus n, which is exactly what we're applying here, adding the exponents when multiplying like bases. Now let's look at how we can model the multiplication of a polynomial by a monomial. In this example, we're multiplying 2x by the binomial x plus 1. Think of it like this. The width of our rectangle is 2x, and the length is x plus 1. When we find the area, it represents the product of these two expressions, which is 2x times x plus 1. Using algebra tiles here is very helpful. It allows us to visualize how each part of the monomial interacts with the binomial. The key idea is that multiplying a polynomial by a monomial scales each term, and the algebra tiles help us see this clearly. This approach is especially useful because it connects algebraic expressions with a visual, tangible representation. It reinforces the concept that the area of the rectangle corresponds to the product of the two expressions, making the idea of polynomial multiplication more concrete and intuitive. All right, let's look at what this model shows us. We have two x squared tiles, which represent the term 2x2, and 2x tiles, representing the 2x term. When we add these together, we get the total area as 2x2 plus 2x. Now notice that we can factor this expression by taking out the common factor, which is 2x. When we do that, we're left with x plus 1. So the entire area can be written as 2x times x plus 1. This visual helps us understand how the distributive property works in algebra, by breaking down the expression into parts that are easier to see and manipulate. It's a great way to connect the algebraic expression with a visual, tangible model. So, by counting the tiles and grouping them, we're essentially confirming that the factored form matches the expanded form, reinforcing this important concept. Let's look at this example to see how multiplying a polynomial by a monomial works in practice. We start with 2y times the polynomial in parentheses, which is 3y2 plus 9. To do this, we distribute the 2y to each term inside the parentheses. So, we multiply 2y by 3y2, and then 2y by 9. When we multiply 2y by 3y2, we get 6y3 because we multiply the coefficients 2 and 3 and add the exponents of y, which are 1 and 2, giving us. Next, multiplying 2y by 9 gives us 18y, since 2 times 9 is 18, and y stays as it is. After that, we write the terms out. 6y3 plus 18y. Notice how we simplify the exponents in the first term to get the final answer. The key takeaway here is that when multiplying a polynomial by a monomial, we use the distributive property to multiply the monomial by each term inside the parentheses, and then we simplify the resulting expressions. This process helps us handle more complex algebraic expressions efficiently. Now let's look at how we find the area of this rectangle. We've already calculated the expression for the total area, which is 6x4y3 minus 2x3y4 plus 10x4y2. To write an expression for the area, we need to think about multiplying the dimensions of the rectangle. Remember, the area of a rectangle is found by multiplying its length by its width. So, in algebraic terms, we're essentially multiplying two expressions that represent those dimensions. This example highlights how algebra can help us understand and calculate areas, especially when the dimensions are expressed as algebraic expressions rather than just numbers. By multiplying these expressions, we're combining the factors to get the total area, which is a key concept in understanding how algebra and geometry intersect. Now let's look at how we find the area of this shape. We start with the expression 8x times 5x squared plus 9x minus 12, and then add 2x squared plus 3. To find the total area, we use the formula for the area of a trapezoid, which is 1/2 times the height times the sum of the bases. In our case, the height is 8x, and the bases are the expressions inside the brackets. So we multiply 2 by 8x, and then by the sum of 2x squared plus 3, and 5x squared plus 9x minus 12. When we combine those, we get 7x squared plus 9x minus 9. Multiplying through, 2 times 8x gives us 4x, and then we distribute that across the combined expression, resulting in 28x cubed plus 36x squared minus 36x. So the final expression for the area is 28x cubed plus 36x squared minus 36x. This illustrates how we can use algebraic expressions and the trapezoid area formula to find the total area efficiently. It's a good example of applying these concepts to more complex shapes.
Modeling polynomials. Understanding real-life applications. What is a polynomial? A polynomial is a mathematical expression. Example, 3x squared plus 2x minus 5. Parts of a polynomial. Term, coefficient, exponent, constant. Types of polynomials. Monomial, 5x. Binomial x plus 3. Trinomial x squared plus 2x plus 1. Degree of a polynomial. Highest exponent determines degree. Example x squared degree 2. What is modeling? Using math to represent real-life situations. Example 1, area model. Rectangle length x plus 3. Rectangle width x plus 2. Area x plus 3 by x plus 2 equal x squared plus 5x plus 6. Example 2, Profit Model. Profit equal revenue minus cost. Revenue equal 5x. Cost equal 2x plus 10. Profit equal 5x minus 2x plus 10. Equal 3x minus 10. Example 3, Motion. Height of object, h equals minus 5t squared plus 20t plus 3. Shows how height changes over time. Graphing polynomials. Graphs show shape and behavior. Example, parabola of x squared. Why use polynomial models? Predict values. Solve problems. Understand patterns. Practice example. Model this situation. A square has side length x plus 4. Find the area. Answer. X plus 4, square equals x squared plus 8x plus 16. Thank you. Please subscribe to my channel for more math educational videos. Exercise 4 to 6. Question 4. 9 squared times negative 4 squared. Multiply coefficients. 9 times negative 4 equals negative 36. Add exponents. A squared times a squared equals a to the power of 4. Final answer. Negative 36a to the power of 4. Question 5. Negative 3b to the power of 6 times negative 24b to the power of 3. Multiply coefficients. Negative 3 times negative 24 equals 72. Add the exponents. b to the power of 6 times b to the power of 3 equals b to the power of 9. Final answer. 72b to the power of 9. Question 6. 8m to the power of 4 times negative 3m to the power of 2. Multiply coefficients. 8 times negative 3 equals negative 24. Add exponents. M to the power of 4 times m to the power of 2 equals m to the power of 6. Final answer, negative 24m to the power of 6. Exercise 11. Choose the correct answer. Multiply. Negative 8c squared d squared times negative 4cd. The correct answer is C. 32c cubed d cubed. Exercise 1 to 3. Question 1. 3x squared multiplied by 4x cubed. Multiply coefficients. 3 multiplied by 4 equals 12. Add exponents. X squared multiplied by x cubed equals x to the power of 2 plus 3, which equals x to the power of 5. Final answer, 12x to the power of 5. Question 2. 7 multiplied by 7x to the power of 4. Multiply coefficients. 7 multiplied by 7 equals 49. Keep the variable part. X to the power of 4. Final answer. 49x to the power of 4. Question 3. Negative 2k to the power of 4 multiplied by 3k cubed. Multiply coefficients. Negative 2 multiplied by 3 equals negative 6. Add exponents. K to the power of 4 multiplied by k cubed equals k to the power of 7. Final answer, negative 6k to the power of 7. Choose the correct answer. Blank plus n multiplied by blank minus n equals 0.36 minus n squared. The correct answer is B, 0.6.